And if I type that yellow expression to the scheme prompt, that's what it's going to return. Now, this method needs to have access to the instance's local instance variables and to its class variables, as well as, of course, the global scheme variables. Does it? Yes, it does. So this is good. But now, what we're really going to do, we're not going to type this to a scheme prompt. We're going to type this. So we're actually going to invoke this method. Okay, here's the method. We're going to invoke it. How do we do that? We make a frame, E5. The procedure doesn't have any arguments, so nothing goes in this frame. What frame does it extend? The one that the right bubble points to, which is E4. And now it says set bang local plus local 1. That's, we're starting to do the body. So do I look up set bang in this environment? Who says yes? Who says no? Come on, everybody has to vote. The seats aren't electrified. Who says yes? Who says no? Okay, somebody who said no, why not? Hand. Right, yeah. Set bang is only defined in the global environment. Thanks for playing. Yes? Thank you. Set bang is a special form. Special forms don't live in the environment. So you ought to remember this from the Scheme 1 interpreter, that eval knows specially about special forms. Okay? I'm crossing my fingers as I say this, because in the most recent versions of Scheme, you can actually create your own special forms that are lexically scoped. You can have like an internal definition of a lexical of a special form, and so they do live in the environment in a special, different way. But in the scheme that is in the metacircular evaluator that we're going to see in Chapter 4, special forms are just built into eval. So we don't look it up at all, not even in the global environment. If it were an ordinary procedure, we would find its definition in the global environment, but we would get there by saying, is it defined here? No. Is it defined here? No. Here, no. Here, no. Here, no. Here. Oh, yeah, here it is. That's why you can't have a formal parameter named list. Right? Remember that from week 1? Because if you had a formal parameter named list and we tried to use the list procedure, we wouldn't find that definition in G. We'd find the one right here. Okay? All right, so we don't look up set bang. It's a special form. The first thing it does is evaluate its second argument, which is plus loc 1. That isn't a special form. It's a procedure call. So we do look up plus, boom, 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 boom. We have to come all the way back here before we find plus, whose value is a primitive procedure. Then we look up loc. It's not here. It's not here. Here it is. Its value is 0. Then we don't look up 1 because it's a number. It's self-evaluating. 1 is 1. So now I can call the addition primitive. How do we do that? By magic. With the arguments 0 and 1, it returns the answer 1. And now setbang says, looks at its first argument, which has to be a symbol, and it says, okay, this is the variable whose value I want to change. Let me look for loc. It's not here. It's not here. Oh, here it is. So I'm going to change it from 0 to 1. Okay? So this is what the diagram looks like with message passing. just for fun. Here's the same thing in OOP language. And so this is what we've implemented. Define class count, class vars, globe 0, instance vars, loc 0, and then two methods. Defined as con clauses. Okay? So a method is a procedure, but in this particular version, it's not a named procedure. We didn't say define local to be set bang blah blah blah, define global to be set bang blah blah blah. We just have lambda expressions right there in the con clause. You could do it the other way too. Some of the examples in the book actually say like define deposit, right? Define withdraw. And then there's a dispatch procedure that says EQ message, quote, deposit, deposit. That works too. Yeah?
Why don't we call the result of Q1 local inside the on-cause anyway? Why do we have to put in?
Why don't we call, oh, why did we put a lambda around it instead of just doing it? Because if the message took arguments, we would need a way to do that. The dispatch procedure always only takes one argument, namely message. Okay? So if you want to have arguments to your method, they would go right here, inside that lambda. And so then we would have to call that with the actual arguments. Was that your question too? Okay, yes?
Would it be possible to add a splat or whatever to the end of the dispatch procedure and have it
To add a what?
like a splat, like a
Splat.
period and then parse and then
Oh, I see. Couldn't we write dispatch to take arguments? Yeah, we could. It turns out to be really valuable to be able to treat the method as a thing. For example, consider inheritance, okay, where we end up saying, hey, parent, do you know how to do this? Okay? Before we actually try calling the thing with arguments, we have to see if it exists. So we call the dispatch procedure, and we write our dispatch procedure so it says something like else false. This one says else an error message. But if you want to do inheritance, you write it so it says else false. And then the child asks the parent, hey, can you handle this? And maybe there are multiple parents. So first it asks the first one, and then et cetera. So then what we end up with eventually is a method, and then we can invoke that. Was that a hand up? No, it's a hand wave. Okay. Yes? Oh, what's in blue here? I said, suppose I said define C2 to be make count. I didn't actually do it, but this is what would happen. We would duplicate the stuff in red coming off of E1. So this is the steps of defining C2 to be this procedure right here. Okay? I just did it really quickly. Yeah? Can we use ask? If we define it, yeah, like that. It is automatically defined in our OOP system, yes. And it looks just like that. Oh, so you're saying since it's automatically defined, couldn't I use it here? I wonder if that's true. Oops. Huh, look at that, it works. Okay. Yeah, but that's what it's doing. It's doing the two steps. Yes? Yes, instantiation variables would go in E2 if there were any. Okay. Yeah, good question. All right, I'm tempted to actually show you some of this stuff that you're asking about. So let's go ahead. Let me go ahead and do what I suggested earlier. Say EQ message, quote, reset, lambda of new, set bang, loc, new, quote, okay. Note, by the way, that C1 and C2 don't have that method. And, oh, don't I have to reload this? Yes, I do. Thank you. And also notice that C1 and C2 don't have the same class variable as C3, because I defined a new class. So C3 is not going to be a member of the same class as the others. Okay, so now I can say open. C3 quote, well, yeah, let's just start with local a few times. Now I'm going to say C3 quote reset, and that gives me a method which I'm going to call with the argument 20. It says OK. And now if I say C3 local, I get 21. Okay? So that's an example of writing a method that takes an argument. Back up here, lambda of new.